Everyone thinks Earth is unique in its climate stability. They're wrong. Venus proves how easily it can shatter. Our closest planetary neighbor, Venus, once held a striking resemblance to early Earth. Similar size, similar mass, and perhaps even similar conditions. It was a world that might have cradled vast oceans, a milder atmosphere, and even the potential for life. But something went catastrophically wrong. Today, Venus is a hellscape. Surface temperatures hot enough to melt lead, an atmosphere dense with carbon dioxide and sulfuric acid clouds, and pressures equivalent to nearly a kilometer beneath Earth's oceans. It's a runaway greenhouse effect taken to its most extreme conclusion. For decades, scientists pondered this dramatic divergence. What specific chain of events transformed a potential twin into a planetary inferno? The answer lies in a delicate balance, one that Earth currently maintains, but which Venus irrevocably lost. The story begins with the Sun. Both Earth and Venus started with a younger, slightly dimmer star, but Venus, being closer, received about 40% more solar radiation. This seemingly small difference became a critical factor over billions of years. Initially, Venus likely possessed a significant amount of surface water, perhaps even global oceans. This water would have helped regulate its early climate, absorbing carbon dioxide and moderating temperatures, much like Earth's oceans do today. However, with the increased solar radiation, Venus's oceans began to evaporate at a faster rate. Water vapor, a potent greenhouse gas, started accumulating in the atmosphere. This trapped more heat, leading to even more evaporation, a dangerous positive feedback loop. As the upper atmosphere became saturated with water vapor, ultraviolet radiation from the sun began to break the water molecules apart, a process called photodissociation. Hydrogen atoms, being light, escaped into space, while oxygen reacted with other elements or was lost. This was a critical turning point. Venus was literally losing its water, molecule by molecule, into the void. Without liquid water on its surface, the planet's ability to absorb carbon dioxide from its atmosphere was severely diminished. On Earth, plate tectonics plays a crucial role in the carbon cycle, recycling carbon dioxide back into the planet's interior through subduction. Venus, however, lacks active plate tectonics in the same way. Its crust is thought to be a single, stagnant lid. Volcanic activity on Venus continued, releasing immense amounts of carbon dioxide into an atmosphere that could no longer effectively remove it. This CO2 accumulated, thickening the blanket of gas and trapping even more heat. The result was an unstoppable spiral. More heat led to more evaporation, which led to more water loss, which led to more atmospheric carbon dioxide, which led to even more heat. The greenhouse effect spun out of control, reaching the extreme conditions we observe today. Missions like NASA Magellan in the early 90s and more recently JAXA Akatsuki have provided invaluable data. Magellan's radar mapping revealed a surface shaped by extensive volcanism, consistent with a planet that periodically resurfaces itself in massive global events. These global resurfacing events, potentially caused by heat buildup beneath the stagnant crust, would have released catastrophic amounts of CO2 in relatively short geological periods, accelerating the runaway effect even further. The atmospheric pressure on Venus is 92 times that of Earth's. Imagine standing under a mile of ocean just from the weight of the air above you. This immense pressure, combined with the searing heat, makes any direct surface exploration incredibly challenging. The sulfuric acid clouds, which obscure Venus's surface from visible light, are another byproduct of this extreme environment. Sulfur compounds, likely released by volcanism, react in the atmosphere to form these corrosive aerosols, contributing to the planet's hostile nature. Venus stands as a stark warning. It illustrates the fragility of planetary climates and the potential for a positive feedback loop to transform a habitable world into an uninhabitable one. It's a powerful lesson in planetary evolution. Future missions, like NASA Da Vinci Plus and Veritas, aim to delve deeper into Venus's atmosphere and surface. Da Vinci Plus will send a probe through the atmosphere, analyzing its composition, while Veritas will map the surface in unprecedented detail, revealing its geological history. These missions aren't just about understanding Venus, they're about understanding Earth. By studying how a sister planet went so wrong, we gain invaluable insights into the mechanisms that keep our own world habitable and the consequences of disrupting them. The dark side of Venus isn't just a fascinating cosmic tragedy. It's a profound cautionary tale etched in the very fabric of our solar system, a reminder of the delicate balance that governs all life. Explore how Earth maintains its delicate balance in our next deep dive into planetary science.